Okay, so binomial radical expressions. Remember, a binomial means it has two terms. So here we're looking at things with two terms, and it's asking what is the simplified form of each expression. Notice in part A, okay, that those two expressions have a common factor of the square root of 7bc. So it's almost like you could think about factoring that out, and you would still have 14a plus 5a. So you would have 19a still being multiplied by this radical. So in this case, we would get 19a times the square root of 7bc. So again, this is basically like adding like terms, but my point is you really need to make sure that you have this common radical. It has to be the exact same radical, same index, same factors underneath the radical. In part B, okay, you'll notice that one says the fifth root of x and one says the fifth root of 3x. If we just tried to do the same thing we just did, we still have these, and these can't be combined together. So really, there is no way to make this one term. It's going to remain 2. Okay? All right, for this problem, so it says here's a tile made of congruent right triangles with a base of 1 and a height of 2. Find the perimeter of the tile to the nearest tenth of a foot. So these triangles are right. So basically each triangle is looking like this. Base of 1 and a height of 2. Okay. So notice that to find the perimeter, I need this, okay, which is basically the hypotenuse of the triangle. So a little reminder of Pythagorean theorem. A squared plus b squared equals c squared, or leg squared plus leg squared equals the hypotenuse squared. So I get that c squared is 5, which means the hypotenuse has a length of rad 5. And I don't include plus or minus there because I wouldn't have a negative distance. Now, there are 4 of these around there, so I would be thinking about this as rad 5 plus rad 5 plus rad 5 plus rad 5. Or I would be thinking about this as 4 times rad 5. And either way, even if you added them up as like terms with those ones in front, you would get 4 rad 5 feet are the units here, as our perimeter of those triangles. All right, so to write this in simplest form, at first glance, it appears that you can't because the radicals don't have anything in common. However, if we simplify the radicals, so notice 4 is a perfect square, so we would have 2 rad 7. And with 175, I know that 5 goes into that. So I see a perfect square of 5, so that would be 5 rad 7. And then 63, 9 is a perfect square, so I'm going to have 3 rad 7. So all of these have rad 7, so they can all be combined like like terms. So we're going to do 2 minus 5 plus 3. So that's going to be negative 3 rad 7 plus 3 rad 7, which actually in this case is just going to be 0. All right, so multiplying, when we multiply these, we're going to use the distributive property or FOIL. So 1 times 4 would be 4. 1 times 3 rad 7. 4 times 2 rad 7. So remember, when you're doing 4 times 2 rad 7, these get multiplied. The 4 can't just jump inside the radical, okay? And then 2 rad 7 times 3 rad 7 is going to be 6 rad 49. Okay? So these two are like terms. And then we have our 4. And then here, this is really 7, and 6 times 7 here is 42. So 4 minus 42 would be negative 38. And then we have our 5 rad 7. And these are not like terms because they have different radicals, so we can't combine them together. Okay, so the same thing for part B. 5 times 5 is 25. 5 times 3 rad 2 is negative 15 rad 2. 5 times 3 rad 2 is positive 15 rad 2. Then we're going to have a negative 9 rad 4. Okay. So when we're we're looking at these like terms, these are like terms and they cancel each other out because they add up to 0. So we have 25, and then this is really 2, and 9 times 2 is 18. So we have 25 minus 18, which is 7. Okay? So just notice that 5 plus 3 rad 2 times 5 minus 3 rad 2, you had no radicals in the solution. Okay? When these two multiply together, these are called conjugates. These two things. All right. Kind of like with our imaginary numbers. So why would we want to know that for problems like these? If I have 11 over 6 plus rad 3, and I don't want this radical in the denominator, then I'm going to multiply 6 plus rad 3 times 6 minus rad 3, and then I have to do the same thing in the numerator. The reason that's my choice is because remember what's going to happen here in the denominator. I'm going to get 36 minus 6 rad 3 plus 6 rad 3 minus rad 9. These are going to cancel out, and rad 9 is really just 3. So in my denominator, I have 33. And in my numerator, I'm going to distribute this, and I'm going to have 66 minus 11 rad 3. And then I can't combine like terms in the numerator, and there's no common factor between numerator and denominator. So that would be simplest form. So same thing with the next one. So the conjugate of rad 3 minus rad 5 would be rad 3 plus rad 5. So I'm going to have 2 rad 21 plus 2 rad 35 over the square root of 9 plus the square root of 15 minus the square root of 15 minus the square root of 25. So these will cancel, and this is just 3, and this is just 5. So my denominator is really 3 minus 5, which is negative 2. And then notice that everything has a common factor of 2. So if you were to cancel that factor out, you'd have the square root of 21 plus the square root of 35 over 1. But you have to account for this negative, so I would make the whole thing negative. Or you could distribute it through. And then you'd have your result. All right, so it's not going to change if there's a variable in it. We can't really do anything for the variable, but again, we just want to rationalize the denominator. So the conjugate of 3 minus rad 6 is 3 plus rad 6. And so we'd get 12x plus 4x rad 6 over 9 plus 3 rad 6 minus 3 rad 6 minus rad 36. This is really worth 6, and these cancel out. So 9 minus 6 is 3, and I have 12x plus 4x rad 6. I can't combine the terms in the numerator because even though they both have x, they don't both have the rad 6. So that is as simple as this expression can get. So that's it for my radicals with binomial.